earlier we saw the magic of Spring Data JPA, right? So we had our entity type of employee and our primary key of integer. We plug that in and it will give us those methods for free for finding, saving, deleting, and so on. And this really helped to eliminate the boilerplate codes. And we saw this little diagram earlier, right? The coding before Spring Data JPA and the coding after Spring Data JPA. Made it really easy, no implementation class, pretty awesome. And I wonder like, can this same thing apply to REST APIs? I wonder. So here's the problem. We saw to create a REST API for employee. We would set up our employee REST controller, inject a service, set up the get mappings, post mappings, and so on. We'd set up our service interface, our service implementation. And then we also had our application architecture. We had our REST controller, our service, our repository, and that worked fine and all. But what if I needed to create a REST API for another entity like customer, student, product, or book? Would I have to go back and repeat all of the same code again? And I don't want to do that over and over again for each entity. I wish we could tell Spring, hey, create a REST API for me. Use my existing JPA repository, my entity and primary key, and give me all of the basic REST API CRUD features for free. So Spring Data REST is the solution. It's a separate Spring project. You can use it with regular Spring or Spring Boot. It leverages your existing JPA repository, and Spring will give you a REST CRUD implementation for free. And the nice thing here is that it helps to minimize boilerplate REST code. And in fact, there's no new coding required to get set up with this Spring Data REST. So Spring Data REST will expose these endpoints for free. So you'll have methods for posting to create a new employee, get to retrieve, put for update, and delete for, of course, deleting an existing employee. And you get all of these REST endpoints for free when you make use of Spring Data REST. And again, just like magic. So you may wonder, how does it work in the background? Well, Spring Data REST will actually scan your project for JPA repository sub-interfaces. It'll expose the REST API for each entity type for your JPA repository. So in this example here, I have this employee repository, extends JPA repository. We have this entity type of employee. It'll actually expose an employee's endpoint. So a bit more on the endpoint here. So it'll create the endpoints based on an entity type, and it'll make use of the simple pluralized form, meaning it'll take the first character of the entity type as lowercase, and then it'll simply add an S to the end of the entity. So in this case, we have this employee repository. The entity type is employee in brackets, and it'll create a /employees endpoint. All right, and so that's the basic approach for how they'll expose these REST endpoints. Now, I'll talk more about the pluralized form later in some later videos, and also how you can kind of customize it. But for now, we'll kind of take this out of the box. All right, so let's look at the actual development process. So for the first step is add in the Spring Data REST to your Maven POM file, and that's it. There's absolutely no coding required. You simply make a Maven POM entry and you get these endpoints for free. So a bit more here on step one is adding it to your POM file. So you simply give a dependency here and you give a reference for Spring Boot Starter Data REST. And that's it. No coding required. Spring Data REST will scan for JPA repositories and expose endpoints. And so you'll get these endpoints for free based on the various entity types in your JPA repositories. So for Spring Data REST, you only need 3 items. You need your entity type of employee, the JPA repository, and then also the Maven POM dependency for Spring Boot Starter Data REST. So the first 2 items, we already have those. The only new item here is number 3, the Maven POM dependency. And then that's it. Now, some changes to our application architecture here. So before, we had our employee REST controller, we had our employee service and our repository on the back end. And now after we're using Spring Data REST, they'll give us a /employees endpoint for free. So there's no additional coding required to get this given REST endpoint. So in our original architecture up top, we can delete the code from our employee REST controller and also delete the employee service. We no longer need that code because Spring Data REST will provide that functionality for us for free. And I like free stuff. Now with minimizing the boilerplate code, so before Spring Data REST, we had our REST controller, we had our employee service, we had our service implementation. So about 3 files and 100+ lines of code. And then after Spring Data REST, you're going to love this, right? No coding required. Just give a Maven POM entry. Spring Data REST will scan for those repositories and automatically expose those endpoints for free. You can easily see that we no longer need the original code on the left-hand side because Spring Data REST will give us all of that functionality for free. The Spring Data REST endpoints are Helios compliant. So what is Helios? It's the hypermedia as the engine of application state. Blah, big acronym. Basically hypermedia-driven sites that provide information to access our REST interfaces. And so really you can just think of this as metadata for the REST data that's coming back from these given REST APIs. You can read more about Helios at this link here at spring.io, but I'll actually go through some quick examples to show you the basics of how this Helios works. Spring Data REST responses make use of Helios. So for example, a REST response from get employee 3 to get a single employee, then it'll return this JSON data as a response. So up top, we'll actually have our content or our real data like our employee data, first name, last name, email for a given employee. And then at the bottom, we actually have response metadata. So this metadata here basically has links to the actual entry or the data. So this is for employee ID of number 3, just a way of describing the data or linking to the data. Now for a collection, the metadata includes the page size, the total number of elements, the pages, and so on. So if I wanted to get a list of employees by doing get/employees, then the JSON response will be this piece of information here. And up top, we have an embedded, a JSON array of employees for all the different employees there. And then down at the bottom, we have metadata about the page or information about the page. So the size of the page, the total number of elements, pages, number, and so on. And I'll talk more about configuring the page sizes a little bit later. So for details on Helios, see the link here at spring.io. Helios also makes use of the Hypertext Application Language Data Format, or HAL, and that's the actual format of the JSON data that's being returned in the response. So if you'd like to get more information on HAL, you can see the link here at the Wikipedia website. Okay, so let's go ahead and get started. And the first thing I like to do is move into MySQL Workbench and just refresh our database table just so we have some standard data to start with. So again, using that employee script, just go ahead and execute it just so it can update everything for us. And then the standard drill, right? We'll simply copy paste the previous project. Now let's go ahead and move over to our IntelliJ preferences here, and we'll set up those IntelliJ configurations. And let's move down to the item here for build, execution, deployment. Expand this for a second, and then we'll choose compiler. And then we'll select this checkbox here, build project automatically. Alrighty, so that looks pretty good. And now let's go and select the advanced settings item. And then in the compiler section, we'll check the box, allow auto make to start. And remember, these are the little IntelliJ configurations that we need to do for the community edition to allow it to work with Spring Boot Dev Tools. So I'll start by opening up the pom.xml file. Let me expand the window here for a second. And so basically step one is adding the Spring Data REST to the pom.xml. So I'll just scroll down here in the file and write a quick little comment to myself. So I need to add that dependency for Spring Data REST. What I'll do is simply copy one of the dependencies from up above and simply just paste it down here and make a quick update to it. All right, so that was the little copy paste exercise. And now I'll simply change this entry here, this artifact ID. I'll change it to data REST. All righty, that looks good. So that's our updated entry here for Spring Data REST. And so remember, that's it. Absolutely no coding required. Spring Data is going to scan for JPA repositories and give us those REST endpoints for free. So the next thing I'll do here is delete the controller and service packages, because remember, with our new architecture, Spring Data REST is going to give us those REST endpoints for free. So I can actually delete the code for the employee REST controller and also delete the code for the employee service. It's no longer required in our project. So I'll just move in here for the REST package. I'll go ahead and delete the REST package. And I'll also do a similar thing here. I'll delete the service package. Okay, great. So at this point, I should simply have my entity, employee, the DAO package of the employee repository, and finally the main Spring Boot application. And then just remember, for Spring Data REST, we only need 3 items: our entity, our JPA repository, and that Maven POM entry. And that's all we need to get those endpoints for free. All right, so let's go ahead and run our application and let's test it out. Okay, so our app is up and running. I'll move over to a web browser and I'll access localhost 8080/employees. And boom, it works for us. So there's our data. So we're actually getting our list of employees: Leslie Andrews, Emma Baumgarten, and so on. So this is all coming back thanks to Spring Data REST. And also it's making use of this Helios format as far as the actual data and the structure of the data as it's being passed back. And also we have the metadata here at the bottom for this given page, the size, total elements, total pages, number, and so on. All right, and so we can confirm that this data is really coming back using Spring Data REST. Good job. And I can even make use of some of the links here to drill down for like employee 1. I can select this link and it'll take me to the details here for employee 1. Okay, there we go. So this looks pretty good. So Spring Data REST is up and running. So I want to play around with some other features here of Spring Data REST. So what I'll do is I'll take this URL, I'll copy it, and I'll move over to Postman and paste it in there. And check the results here in Postman, and yep, same thing. So we're getting the data back as desired in Postman also. Okay, so one thing I'd like to do is actually customize our endpoint base path, just to kind of give us a little bit more control over that given URL. So I'll open up my application.properties file and add some Spring Data REST properties. So I'll give Spring Data REST.base path, and I'll call it Magic API. So that's the base path for the URL that we'll have for these Spring Data REST endpoints. And then I simply save this file, and we'll see at the bottom that it's reloading, which is pretty cool. And now if I swing back over to Postman, then I can access this information. So first off, if I simply use the existing /employees, it's going to give me a 404 of not found. That's because we've actually changed the actual base path. So here I have to say Magic API /employees, and that's based on the information from that configuration file. So now when I hit send, I'll actually get the data back as desired. All right, so great. So it's using our Magic API. And you can use any base path that you want here. So now let's go ahead and play around with posting or adding a new employee. So I'll select the tab here for post. Make sure that you update your URL for Magic API. And then for the body, you may already have some existing data here. You can keep it the same or you can change it. I'll go ahead and keep mine as is for Natalia. And I'll simply send that across. And then just scrolling down to the bottom, we'll see that we have success. It added that new employee, Natalia, and she has the ID of 6. So the employee ID will show up in the Helios metadata section. Just swinging over to my database real quick and just doing a quick refresh here. And so we see that Natalia is the new entry here of ID of 6. So this looks pretty good. Now we'll also go through and using a put to actually update an employee, and make sure you update your URL here for Magic API. So let's perform an update on employee ID equals 4. And so one thing that's different here is that Spring Data REST only uses the ID on the URL. So don't pass the ID in the JSON body like we did before. Only place the ID on the URL. If you place the ID in the body, it'll simply ignore it. It'll only use the ID on the URL. All right, so I'll select body over here, and I can give some new updated information. First name of Papa, last name of Ray, just again, making this up. And then once we send this across, then we should update employee ID of 4 with this new data that we provided here, first name, last name, and email. So we can kind of scroll down to the bottom. It'll show us that update for ID 4. And if we just swing over to our database, we can see our old data of ID 4 was Yuri. And I simply do a refresh here, and I'll see the first name of Papa, last name Ray. That's the data that we just sent across. So it successfully updated that given employee ID of 4. Alrighty, so swinging back into Postman, I'll go through and delete an employee. Alright, so I'm making use of delete. And again, just make sure you update your URL here, Magic API /employees/4. So we're going to delete employee number 4. And just do a send. Alright, so we have a success here. With Spring Data REST, there's no data in the response body. they simply give you a status code of 204. So that means that it was successful, no content. So this is fine. We're good to go here. So swinging back to our database, we see that ID equals 4, pop array, that's our old data. Simply go through and do a refresh, and we'll see that that given employee was deleted successfully. So ID equals 4 was deleted. All right, so that kind of covers all the CRUD stuff. So we know that Spring Data REST is working out just fine for our CRUD operations with our given database. And again, we simply added this functionality by putting in the Maven dependency here for Spring Boot Starter Data REST. And again, no coding required. And in fact, we actually went through and deleted some code, okay? So this minimized the boilerplate code. So we removed all the REST controllers and all the service impls, got rid of all that stuff, and we simply made use of the Maven entry, and that will give us those REST endpoints. In this video, we'll cover Spring Data REST configuration, pagination, and sorting. By default, Spring Data REST will create endpoints based on the entity type. So the simple pluralized form is the first character of the entity type is lowercase, and then Spring Data REST will simply add an S to the entity. So in this example here with employee repository, it sends JPA repository. The entity type is employee, so it'll have a /employees. And that's a very simple, most basic format. So the Spring Data REST pluralized form is very simple. Like I mentioned earlier, it simply adds an S to the entity. But the English language is very complex, and Spring Data REST does not handle any of these special cases like goose, geese, person, people, syllabus, syllabi. And that part, Spring Data REST just falls apart. So this is a problem. Spring Data REST does not handle complex pluralized forms. So in this case, you need to manually specify a plural name. Also, what if we wanted to expose a different resource name? So instead of /employees, we wanted to use something like /members. Here's the actual solution. So we can specify the plural name or path with an annotation. For our employee repository, we make use of this new annotation here called @repository REST resource, and then we give a path. So in this example, I have path equals members. So then we'll have the actual endpoint URL of localhost 8080 /members. So instead of using /employees, it'll now make use of /members. And then in regards to pagination, by default, Spring Data REST will return the first 20 elements. So the page size is 20, and then you can navigate to different pages of data using different query params. So here I could say, give me localhost /employees, page 0 or page 1, and so on. And the pages are actually 0 based. So the first page starting at page equals 0. Now, Spring Data REST has the following properties that we can set in application properties. So one of them we've seen already, Spring Data REST.basePath. That's the actual base path for the repository resources. We can also set the default page size, and we can also set the max page size. There are more properties that are available. Simply go to lovetocode.com/springbootprops. It'll take you to the official Spring docs, and simply scan that list for Spring Data REST.star properties. Okay, so here's an example of a sample configuration that we can set in our application.properties. So here I have Spring Data REST.basePath equals /magic API. And so this will basically give us the endpoint /magic API /employees. And then we can also set the default page size equals 50. So it's going to return 50 elements per page. Okay, now in terms of sorting, we can sort by the property names of the entity. So in our employee example, we have first name, last name, and email. To sort by last name, and the ascending is the default, I could say /employees sort equals last name. I could also sort by first name descending. So I have /employees sort equals first name, DESC for descending. I could also sort by last name, then first name, ascending. So here I have sort equals last name, first name, ASC. And I actually don't need the ASC here. It's the default, but I just listed it here just to be explicit, just to show you an example of using that in the actual query param. All right, great. So we'll go ahead and switch over and move into Eclipse, and we'll try out some of these features. Okay, so let's move into Eclipse and we'll work with configuration, pagination, and sorting. So the first thing I want to do is go through and just do the housekeeping stuff, stop any apps that are already running. And the first thing I'll do here is configuration. So I'm going to change the REST resource path. So instead of employees, I want to change it to something else. So I'll open up my employee repository and I'll add a new annotation here. So I'll give this at repository REST resource path equals members. So Spring Data REST, instead of exposing /employees, it'll expose /members for this given REST repository. So I'll go ahead and run my application and test it out. So I'll kind of move into Postman and I'll duplicate one of these tabs here. So I have this tab, Magic API /employees. Now if I do a send, I'm going to get a 404 not found because we changed the path. So we really should make use of /members because that's what we set up in our annotation. And so now when I do a send, then everything works out successfully for us, works out just fine. So that just shows you how you can change the actual endpoint for this given repository. And what I'll do is I'll actually kind of just remove this or comment it out because I want to go back to making use of my /employees here. So I'll simply comment out this code for right now. And then I'll just do a quick verification on it over here. So I'll close off that tab and I'll go back to my normal Magic API /employees and cool. So this is working as desired before. So this is good. Now let me scroll down here a bit. And so down at the bottom for this given collection, we'll see information about the page. So this is metadata about the page. So the size, the total number of elements, pages, page number, and so on. And what I want to do here is kind of move over and actually change the default page size. So I'll set up this property here, Spring Data REST.default page size equals 3. That means for every request, we'll only get a page size of 3. So we know our database has 5 elements. So our page size right now is 3. We have 5 elements in the database. So that means that we have a total of 2 pages, right? You know, kind of do the little division there. So we have 2 pages. And then one thing that's important here as far as the actual page numbers is that the page numbers are 0 based. So the first page is 0, the second page is 1. All that funny 0 based stuff. So I'll go ahead and select the link here to go to the next page. So this will open up a new Postman tab for me, pre-populated, and I'll simply do a send here. And this will give me information for the next page. So I'll have the remaining 2 elements here for Juan Vega and Natalia Kublinov. Because we have 5 elements, but the page size is 3, so we get 2 pages. Alrighty, so I'll swing back and change the default page size, and I'll change it to 20. Just do a save. It'll reload everything for me, and we're A-OK. I'll just swing over to Postman real quick and just do a send on the list of employees, and just to make sure I get everybody back, and also that the page size is 20. Okay, so we're good to go there. So next we'll look at sorting. So here I'll sort by the last name. So I basically give sort equals, and I give the property name. So sort equals last name. So it's going to sort by last name in the ascending order. So I'll do send, and so I get the data back, sorted by last name, ascending. So here we have Leslie Andrews, A, Baumgarten, Gupta, Kuplanov, Vega. Again, sorting by last name, ascending. Now let's go ahead and switch it up here, and let's sort by last name, descending. So I simply give a comma, DESC for descending. Then I hit ascend over here. And now we get it sorted by last name in a descending fashion. So Vega,